Hello, my name is R.Manonmani and I am a grade 10 student from Maharshi Vidya Mandir Senior Secondary School in Tengasi. Here I have made the model of a double pendulum using popsicle sticks and coins. The aim of my model is to demonstrate what chaos is in physics. So when I lift the stick to a certain height and then I let go of it, you can see that not only does this stick move, it also makes this stick to move. If I try changing the angles with which I let go of the stick, you will see that with the difference in angles, the motion of the whole system also keeps changing. So why does this happen? Why does the angle with which I let go of the stick affect the motion of the pendulum? This is because of chaos. So the basic physics behind this is that when I pull the stick, I am storing potential energy in it. When I let go of this stick, the potential energy gets converted to kinetic energy. This stick transfers some of its energy to this stick, causing it to move, and similarly, this stick also transfers its energy to this stick. This exchange of energies is in an unpredictable way, therefore, they end up in completely unknown paths. This is what we call as chaos in physics. Chaos basically means that tiny differences in the beginning can lead to huge differences in the end, even though all the laws of physics are obeyed and followed. So why does this model become chaotic? This is because this model is non-linear, which means that doubling the angle does not double the effect. In fact, these tiny differences can lead to unknown paths and it's quite unpredictable in the end. To measure this in fact, we have differential equations that measure the relationship between the angle over time. But since measuring the motion or calculating the motion of these pendulums would be quite complicated and we might need computers for it, we are not doing that now. What matters here is that both the angles of both these arms depend on each other in a messy and tangled way. This tangled relationship is what leads to chaos. In short, we can say that the double pendulum obeys coupled nonlinear second order differential equations. This naturally leads to chaotic motion. To conclude, we can say that both these arms are pulling on each other. Since the forces depend on the angles, the difference between the angles and the square of speed, it leads to chaos. This nonlinearity is what makes small differences lead to huge differences. What seems to start same and equal in the beginning ends up in completely different paths. This sensitivity to initial differences is what we call as chaos in physics. Thank you. I hope you enjoyed my project.